Okay, yeah. So we've got still a little bit of ways to go here. We've done a lot already. So the last thing I want to talk about for this section is zeros of polynomials. So p is a polynomial, or p of x is a standard form, such as this quadratic here. In this case, x squared minus 3x plus 2. Sometimes it helps to factor it, especially in this situation. So the definition here is C is a zero of a polynomial P if and only if P of C is zero. So what number do you plug in to get zero? Because, well, factoring really helps because when you factor it, the only way to get zero is if one of the two factors is itself zero. So, well, it's 0 times something, and the only other way to get 0 is if the first factor is in fact 0. So 2 times, so it's negative 1 times 0, or in the other case, it's 0 times 1. Either way, it's 0. Anything else, if you plug in a 3, you get not 0 times not 0, which is equal to not 0. And so, you plug in a 3 into this equation, you'll get not 0 here, because you'll get not 0 here. You'll get, like, 1 times 2 is equal to 2. And that's kind of interesting. You plug 3 into this, you'll also get 2, because, 9 minus 9 plus 2. So, yeah. That's the usual idea. So this is something we've kind of done before, but we're going to take it like one step further. We want to talk about not just zeros, but we want to talk about this concept of multiplicity. So just as one example of what we've seen so far with quadratics, g of x is equal to, let's do 16x squared. There's a couple reasons I like this example. Okay, so what is going to go on with this one here? Well, this is actually that one is actually 6 squared. And on the homework, there's one problem where that's about zeros with multiplicities, and you have to remember that this comes up often enough that it's a pretty good one to have memorized. A squared minus b squared, that one always factors into a minus b times a plus b, because the middle and the outer cancel, and then what's left over, you always get the same thing. So it's let me write it this way. So the 16x squared is, well, the 4 is squared and the x is squared. So I can write it this way if I want to. And that's playing the role of A. Okay, let's see here. The marker. We got something playing the role of B. So B. Here's A. So we have 4x in parentheses squared. So we get 4x. Let's just use a little bit of red here. 4x plus something, or I wrote it in the other order, but anyways, one of them is minus, the other one is plus. But let's just do it exactly the same. So 4x minus 6 and 4x plus 6. So it takes a little bit of extra time to use the colors. If you're having trouble understanding something, the colors can help a lot. If you already understand it, then maybe it just slows you down. But there you go. So what do we get? Yeah, we get, well, 4x minus 6 equals 0, which would mean x is equal to, you add the 6 and divide by 4. And similarly, 4x plus 6 equals 0 when x is equal to negative 6 quarters or negative 3 halves, which is the same as negative 1.5. Let's draw that a little cleaner. There we go. Actually, before I talk about the next concept, I want to do one more example. Well, there's one thing that hasn't happened yet, and that's this. This one's really special because we factor this. Sorry, the previous problem, it was 3 halves and negative 3 halves were the zeros. And for this brand new problem, zero or zeros, what do we have? We only have one zero actually, so x, the only way to make that 0 is both of the factors are x plus 2, so x has to be equal to negative 2. All right, so that's a little weird. There are two factors, but there's only one 0. That's a little bit weird, a little bit suspicious, and it's kind of important. And there's a whole name for this phenomenon. It's called multiplicity. It's also about the name of a movie about I think it's Michael Keaton's the actor. He makes copies of himself, and he thinks it's going to solve all of his problems, but then, well, the whole problem is that he made copies of himself, and all of his copies are just as lazy and selfish as he is, and I'm getting off topic here. Anyways, multiplicity. So, not the 90s comedy thing, but for polynomials. All right, so this definition is a little bit overwhelming. There's a lot of stuff here, but I just want to draw. Just think of it as a pattern. So you've got what happens when you factor things. Well, you might have x minus 1 times x minus 3, and then x plus 7, and you might have x minus 1 squared or x minus 3 to the 5th. So, and then there's also this unfortunate thing that maybe you don't have, we saw with quadratics that sometimes the quadratic formula spits out an imaginary number. We have to take the square root of negative 3 or something like that, and we can't do it. It's that any solution like that does not correspond to a real quantity we can model in real life in that context. So we just say that's an imaginary number. We can't, there's no, that factor, that quadratic has no zeros. So sometimes every time that you do have a 0, you can do long division to factor it out, or just any factoring trick that you might have available. In theory, you can always factor out all of the zeros that could ever be factored, and then whatever's left over is irreducible. So such as, here's an example down here. I've already factored it. Like maybe x squared plus 1 is irreducible. So sure, x squared would have to be minus 1 for this to be 0, and that's not a real number that does that. So there is no real number that makes the 0. That's this irreducible thing. What I want to focus on is the ones that you actually can factor out. So in general that can happen, but then what else is there? There might be a bunch where those factors can be 0. So for this example, let's do it like a table. Multiplicity just means that that 0, you factored out an x minus 1, not just once, but there's 3 different copies. This x minus 1 cubed is just x minus 1 times x minus 1 times x minus 1. So x equals 1 is a 0, but there's 3 copies of it because we factored out x minus 1 3 times. There's the next one, we factored out x minus negative 2. So be careful about that. Negative 2 is what makes this 0. You plug in a negative 2 and then this factor is 0, and there you have that factor to the 4th power. Here the x equals positive 4 makes this one 0, and I didn't write anything here, but that's, if I don't write anything, that's the 1st power. So there's an implied exponent of 1, and that's it. So this is the zeros and the multiplicities of this polynomial. Let's, if we wanted to call that p of x. Those are the zeros, and this 0 x equals 1 has multiplicity 3. The 0 negative 2 has multiplicity 4. The 0 4 has multiplicity 1. All right, this next one is tricky because for the purpose of computing multiplicities, the standard is these 2 things actually have the same 0. You plug in x equals 2, you plug in x equals 2. So it's actually the same thing twice. And the way I like to think of it is, for this step, I like to standardize it by, if I have a leftover constant here, I should factor that out. This 2x minus 4 is actually twice x minus 2, so the original parentheses on the outside, but this, on the inside, I factor a 2 out of that, and it's like, okay, if I make the coefficient 1 by factoring out the leading coefficient, then what do I get? I'm multiplying 3 things. I'm multiplying an x minus 2, I'm multiplying another x minus 2, but then there's also a 2 that I factored out. So this is 2 times x minus 2 squared, so zeros. There's 2 with multiplicity. There's 2 is the 0 because that's what you plug in to make it 0. X equals 2 makes x minus 2 0. But there were 2 copies of that factor. We factored out x minus 2 twice. So that's one where you can get tripped up. And you sort of have to be careful about that. And if it means that you have to deal with fractions, then you still need to be careful about it. So let me just give you one more just so you... I want to make sure we really understand this multiplicity, because we've kind of already said everything there is to it, but that coefficient being something other than 1 can sort of disguise things that are actually have the same 0, and you want to watch out for that. So let's look at x squared minus 9 times x minus 3 times 3x minus 1 times x minus 1/3. Okay, so instructions are find zeros and multiplicity. So each multiplicity refers to that particular 0. So to get us started, this x squared minus 9 is just x minus 3 times x plus 3. And then we've got an x minus 3. That's just literally an x minus 3 from the line above. And let's factor a 3 out of here. 3 times x minus 1/3. That's what we're doing here. This is, we just, that one already has a 3 that you can factor out, but then this -1, well, if I had to, these have, the thing that I underlined in red, it has to be the same. So 3 times this. So it's like I multiply and divide by 3, and I factor out the top 3. And then I haven't done this yet either. The one that was already, this one was here, this one in red was that one in red, this one in the underlined in black. It's the same as that. Okay, so let's group the ones that are the same. We've got I have 2 copies of x minus 3. I have 1 copy of x plus 3. I factored out a constant 3. So I've got yes, done this. And I haven't done this yet. X minus 1/3, there were 2 copies of that. So 0. Three with multiplicity 2, because x minus 3 means you plug in 3 to make that one 0. 1/3 with multiplicity also 2, because there's 2 copies of x minus 1/3. So there we are in red. So y is 1/3 with multiplicity 2. It's like that. And then in black here, for the final answer, we have -3 is what makes this middle factor equal to 0. Okay, so just in case you see it, I did not see any problems dealing with irreducible factors or imaginary zeros. So we're not going to worry about that, but you could see it in the future. I wanted to say something that was always going to be true no matter what. And that's this one here. So anytime you have real zeros, then x minus that 0 factors out. And maybe it factors out more than once. And you do it as many times as you can. How many times is the multiplicity? And you do that as much as mathematically possible to do so. Those are your zeros with your multiplicities. Then you get a constant times, maybe there's this, it's either, if there's nothing here, then it's just that the irreducible factor is just a copy of the number 1. Otherwise, it might be something like x squared plus 1, which is my example that I gave earlier. X squared plus 1 is one example of a factor that has no real zeros that might factor out of your equation. But that's it. We had a lot to say here in the previous 2 sections. This one is pretty mechanical, but it depends on how well you can factor. So all your old factoring tricks, especially your difference of squares, and just be really, really careful about this stuff. How often does it happen in the wild? It could happen. Just be aware of it. I think there are 1 or 2 questions where this occurs. These factors, they don't look the same, but that's because the sort of the standard way to always know for sure is you factor out any coefficient and sort of group that on the very, very outside. So maybe factor 2 out of this one. If this one had a 3x, you would factor out a 3. That's one way of organizing yourself so that you absolutely know for sure that the coefficients are the same. And actually -1 would as like a negative x would be the same deal. So maybe let's do just, let me warn you about that. Yeah, sorry. Yeah, I don't mean for these to take forever, but I do want it's like, you know, if me or some other instructor, if we're feeling tricky, this is something that's deceptive that might trick you if you aren't paying attention for it. So let me say what I mean here. I'll try to make it as fast and painless as possible. Okay, so again, let's say this is g of x. Those two, they look different, but x equals 1, x equals 1. They both are 0 when x is equal to 1. But let's just factor out a negative, because I want the x to be positive. So this should be and this is twice x minus 1. So negative 1. This is negative 1 times x minus 1, because that's x and that's minus 1. This is times 2. This is times x minus 1. So we've got negative 2. So we just group those two constants together and multiply. And then we've got x minus 1 squared. Zeros of that are x is 1 is how you make that expression equal to 0. And then there are two factors. So if you just construct a polynomial completely at random and have a computer find the zeros, the most common thing to happen is that you have all the zeros are completely different from each other and they have multiplicity 1. But in theory, you know, you can multiply expressions like this and anything could in theory happen. So we just have to be ready for it. So this one, if we're really checking to see whether you're whether you're being skeptical or really paying attention, well, if you have these two factors at the end of your problem and you recognize that plugging 1 makes this one 0 and then plugging 1 also makes this one 0, well, in your brain you should, if you kind of remember everything that you've done, you'll be like, oh wait, that looks familiar. So if your final answer says x, you know, you have a 0 that's 1 with multiplicity 1 and then 1 with multiplicity 1. If you say that twice, well, whoops, those are supposed to be grouped together. And that's what I accomplish by doing this, is that any place that I have that I factor down to a linear, I always just have x minus a constant where the coefficient on x is just plain old 1. That way it'll automatically look exactly the same as any other copy. So that's just one method of being totally systematic and consistent. And that's how you get the multiplicity. All right, so that'll do it.